Okay, class, let's have an example for tied column. So you have example, design short tied column to carry an actual load of 1850 kilonewton, and then use FC prime equivalent to 21 megapascal, and then Fs equivalent to 124 megapascal. Okay, so you have the solution. For tight column, you have the formula for the applied load. Applied or the actual load. Okay. Then you have your steel ratio, ranges from 0.01 to 0.04. So normally we will use this value. So if it's not given in the problem, so we will use 0.02 in our steel ratio. Okay, so to solve for the area of steel, area gross of concrete, so you have the formula. So you transpose area gross, so therefore you have PO. So PO is equivalent to your P, which is equivalent to the given actual load of 1850 kilonewton. Okay, so to solve for the area gross, you have this from the formula. So to solve for area gross, you have this formula. So your P is given in the problem 1850, and then you have to divide that by 0.85 times 0.25, then your FC prime given, and then rho G or the steel ratio will use 0.02, and then the Fs 124. So therefore you have your AG or the area gross equivalent to 281,561. Okay, and then that is a square column. Okay, short, so maybe we'll have the square column. So using square column, so you have your formula for the area gross of concrete, that is, since that is square, so this is H and this is H. So square, you have H squared. So square root of that is 531. You round it off to the multiple of 10 up. So your H now is 540. Okay. So for the steel reinforcement, this one, you have your rho G is equal to AS divided by the AG. So you have your rho G given or assume that is 0.02. Then your AG is 540, this one, or no, that is 540, the area gross of your concrete. So to solve for the area of steel, that is 5,832 millimeters squared. And then, so in the problem that is not given, so no given main bar diameter, so maybe you can use any, maybe you can use 16 up to 42 millimeter or 36. So maybe you choose you choose up to that bar diameter. So if that is not given the problem, but if that's given the problem, you will use that in your computation. Okay, so but in this problem, so the main bar diameter is not given, so maybe you can use 32 millimeter diameter, millimeter bar. Okay, so you have now to solve for NB. So NB is ES over AB. So using 32, you have your ES 5,832 divided by the area of the circle. So area of this bar diameter. So you have 7.3. Usually you round it up always. So as what I have said, for number of bars, it should be rounded off or rounded up always. So therefore you have 8 bar diameter. Okay, so you have 8 bars. And then to solve for the spacing, using 10 mm, since that is 32 millimeter bar. So for 32 down, you will use 10 mm. Then 32 up, you will use 12 mm ties. Okay, so for the spacing from the ACI specs, you have 16 times the bar diameter, so that is 512. 48 times the lateral bar diameter, that is 480. And then you have the least common column dimension of the dimension, least meaning the smallest. Okay, so that is 540. So therefore you have a spacing of 480. That is the least value. But as what I have said, if that is in SMRF, a special moment resisting frame concrete, will use the ductility of your structure. So normally in the column, the spacing of lateral ties is 150 mm. Okay, but that is for SMRF. Okay, for the in ECP code 2015. But in our computation here, you can use the least value or the smallest value of the lateral ties. Okay, and then you draw the reinforcement details. Okay, so for the reinforcement details, you have the section, the dimension of your column, and then the bar diameter. Since this is 8 main bar diameter, you will provide the additional lateral ties. Okay, and then to solve for D prime, you have here the cover 40 plus the ties 10 plus the bar diameter divided by 2. So D here is from the concrete, and then you have the so D is measured from concrete up to the center. This is D prime. Okay, therefore 40 cover, this is 40. And then 10 mm ties, then the main bar. Okay, so therefore is 40 plus 10 plus the main bar divided by 2. Okay, so you have your D equivalent to 66, and then to solve for x, that is 2x, and then 2 times 66 equals 540. Okay, so this is 540. So x is 204, it should be greater than 150, so it's okay. So therefore, provide additional lateral ties as shown, since that is 8 main bar. And then for the spacing of lateral ties along this line, for L over 4, that is the height of, or the distance in between column, or in the distance in between beams, that is the unsupported length of column. That is for L over 4, your spacing is divided by 2. Okay, and then for at the midspan area, your spacing is the 480 as what we have solved. Okay, so that's the reinforcement detail for the tied column. So let's proceed with problem 10, so which is the spiral column. So you have there the problem: design a spiral column to carry an axial load of 1850 and then 21 megapascal for FC prime, and Fs is 124. So you have the spiral column. So you have the formula for the applied load. Okay, applied load. So you have this spiral AG. So no, that is 100% efficiency. And then for the steel ratio, you it ranges from 0.01 to 0.08, but we'll use the steel ratio of 0.03. Okay, as what we have computed earlier. You have your AG is equal to P over the 0.25 FC prime Fs plus Fs times rho G. So therefore, you have your area gross equivalent to 206,243 millimeters squared. And then for spiral, that is circular. Okay, circular, so this is your diameter. Okay, so the area is pi d squared divided by 4. So therefore, you have your d equivalent to 520. Okay, so for steel reinforcement, the same formula. You have the steel ratio is equal to the area of steel divided by the area gross. So for the area of steel, you have your rho G, or that is the steel ratio, and then you have your area gross. Okay, so therefore you have your area of steel equivalent to 6,371. And then, so in the problem, no given bar diameter for the main bars, so we'll assume, or let's use 32 mm bar diameter. So therefore, you have your number of bars equivalent to 8. So 8 bar diameter. 1, 2, 3, 4, 5, 6, 8. Okay, so that's 8. And then we'll have the spacing of the spiral ties. Okay, so for the spacing, you have this formula. Spacing is equal to 4 times the area of spiral ties divided by the core, concrete core, times the rho S. Okay, so DC is equivalent to D minus 40 times 2, and then your ASP is pi times the diameter of the ties divided by 4. Okay, so you have your DC equivalent to 440 and ASP is equivalent to 78.54. So to compute for the rho S, that is 0.45 AG over AC minus 1 multiplied by FC prime over F prime S. So your F prime S is equivalent to 0.5 of Fs. Okay, Fs is equal to 0.5 of Fs prime. Therefore, your Fs given is 124. So therefore, your Fs prime is 248. So substitute the values. So therefore, you have your rho S equivalent to 0.0151. Okay, and then from the given formula, you substitute all the values to solve for S. So your S computed is 47. You round it off to the multiple of 5 mm down. So therefore, you have your S equivalent to 45 millimeter. Okay, and then check for the spacing. You have 45. It should be greater than 35 but less than 75. So okay. And then you have the steel reinforcement. Another problem involving this tied column is where you have your square tied column. You convert that into circular, or you can have circular, convert that to rectangular or square. Okay, so your PO here is AG times 0.25 FC prime plus rho G Fs, and then the AG equivalent to pi over 4 d squared, where for the square, that is PO 0.85 times AG times 0.25 C prime plus rho G Fs, and then your AG here is equivalent to H squared. Okay, so to convert that into from square to circular, so from square to circular, if you convert that, you will have all the values here to compute for the PO. So if you have PO here, you substitute to that one, so you have the diameter, same as with circle to square. Okay, so that's the formula to use if you convert, you solve for the PO with the given all given data, solve for the PO, and the PO here substitute to this one to solve for AG, and then to solve for D, you have your AG. So therefore, you convert the square column to circular column, and vice versa. Okay.